Hello, everybody. Let's talk about mock project that we have. So in this mock project, we want to first import all the libraries that we have to. So I'm going to import OS, Pandas, SciPy, and Pearson R, PLT, OLS, all of them. Here we go. Now, the data set that we have here is called, let's say, mock underscore project XLSX. Let's import that. Take a look at the head of first 8 observations. So first 8 observations is going to be with df.head and then in parentheses 8. Yes. How many observations and variables do we have? That's given by df shape. So we have 1338 observations and 6 variables. Variables are age, sex, BMI, children, smoker, and charges. So it's a data set about some people that they have been hospitalized. We have data on their age, on their sex, on their BMI. BMI stands for body mass index, number of children that they have, if they're a smoker or not, and how much the hospital charged them. What are the type of each variable? How many non-observation do we have? That's given with df info. Let's run that. We can see that we have 1338 entries and we have 6 columns. And here, like some of the variables, like let's say age, we have 1329 non-null observations. So we have a few null observations there. For age and sex, we have, let's say, for sex and BMI, we have 1338, but for children, again, we have 1328 non-null observations. So obviously, we have some null values, some missing values, yes? First thing that we want to do is to take care of missing values. So first, I'm going to run this df.isNull.sum. With that, you can find how many null observations, how many missing values you have in each column. So column age has 9 rows that they include. They don't have the value for age. Sex and BMI 0. Then column children, we have 10 rows that they don't have the value for number of children. So we want to, for example, get rid of all those rows that we have missing values. Yes. If you want to get rid of all rows with missing values, then all you gotta do is to say this df equals df dot drop na and then parentheses. Yes. And that's it. If you want, for example, this is just for your information, if you want to drop rows with missing values only in, for example, columns age and children, then you would have used this one, df equals df dot drop na in parentheses subset equals age and children, if you want to focus on those 2 columns. But right now, this df equals df drop na is good for us. And we're going to take a look at this df.isNull.sum to see after this modification how many missing values we have. The answer is 0, so we don't have any missing value. That's a good thing. Print the tail of df. Still, the last observation is observation 1338. So we remove those observations with missing values, but we didn't reset the index. Let's reset the index. How? With df equals df dot reset underscore index. And now we want to print the tail of df. And as you can see, now the last observation is index 1318. That's a good thing. So problem is solved. We don't have any missing values anymore, and everything's fine now. As a practice, please pause the video and answer these two questions. Number one, print list of variables. Number two, print different values variable sex takes. So pause the video and answer these questions. Okay, hopefully you have answered them correctly. For list of all the columns, you just say list and then df dot columns. You run that and you get a list of all the columns, age, sex, BMI, children, smoker, and charges. Perfect. Next one is this. What values variable sex takes? Yes. So that one is going to be a value count. So I'm going to say df and then the variable that I'm interested is lowercase s, lowercase e, lowercase x, say df sex, and then value counts, and then parentheses, and then you can see that I have 668 male and 651 female. Perfect. Okay, let's move on. What different values variable smoker takes? Yes. So again, very similar to what we had above. Let's just run this. Oh, let's take a look at the result. 1047 observations is no, no. 270, yes. And then two observations, we have a kind of typo there. NOOO, yes. So we don't like that. We want to change the value of smoker from NOOO to just NO. How can we do that? So we need the index for those two observations, that smoker is NOOO. How can we do this? So it's something like this. df.index and then inside brackets the condition. The condition is that df smoker equals in quotation mark NOOO. Yes. So if I just run this, however, I'm going to get this. If I want it just as a list, I say dot to list and convert this to a list. So as soon as I do this, I get this 18 and 491. So 18 and 491. Now do this. Change the value for variable smoker for observation 18 to no. The answer is this, df.add, and then in brackets, the index number, which is 18, comma, variable name, which is smoker, equals to the new value that you want to have, which is no. Perfect. Let's keep going. Next one is this. Change the value for variable smoker for observation 491 to no. Okay, so it's going to be very similar to what we had over here, but rather than 18, it's going to be 491. So I'm going to change this to 491 and I'm going to run it. Yes. And then also this one. So we did that. So if I do the df smoker value counts one more time, now I can see that I have 1049 no's and 270 yeses. So I took care of that problem, that two of the observations, they were NOOO. Yes. Next thing, do this. We want to do this. Round variable charges to one decimal. So all you got to say, df charges on the left side, and then on the right side, it's going to be df charges dot round one. With that, you can round them to one decimal. Perfect. And as a practice, please do this. Pause the video and round variable charges to one decimal. So, sorry, I meant here, round the variable BMI, because we did charges, yes. Round the variable BMI to 1 decimal. How can I do that? All you gotta do say is this: df bracket BMI equals df bracket BMI but round 1. And then if you take a look at df head, 7 observations, you see that now BMI is rounded to 1, and then also charges is rounded to 1 decimal. Good. So let's keep moving. Okay. What is average charges for male non-smokers? So these are conditional selections, yes. And conditional selection, again, the syntax is if you have only one condition, the syntax is this: df bracket condition. And then if you have more than one condition, for example, 2 conditions, the syntax is going to be something like this: df bracket condition 1, and then and then condition 2. So and can be also, sometimes we have and, sometimes we have or, but again, the syntax is this. Okay, what is average charges for male non-smokers? So we have one condition that, so df bracket parentheses, one condition that df sex equals male, and then another one that df smoker equals no. So that gives me a data set of all male non-smokers. If I just run this, I get all males and all non-smokers. Great. And then I'm interested in average charges. So I say charges, then dot mean. And I get 8,090. Next one, how many men have 2 children or more? How many men have 2 children or more? So again, I have 2 conditions. Condition 1, sex must be M, male. Condition 2, number of children must be greater than or equal to. And then if I run this, I get all males with 2 or more children. And then I want to just count how many. So if you take a look at children, they're like greater than 2. Then I want to see how many observations I have there. All you got to do, if you want to count this, count the number of observations, is to say that just dot shape and 0. Perfect. So just run this and 222. Now, as a practice, do these 2 questions. What's the average charges for women with BMI 30 or less? It's one question. Question 2, how many men smoke? So pause the video and answer these 2 questions. I hope you have done this correctly. Let's do the first one. df brackets condition and another parenthesis for the second condition. So what's the average charges? And then off the top of this, I'm gonna do, let's say, let's do the conditions first for women. So df sex must be female. Condition 2, df BMI must be 30 or less. So if I run this, I get only females with BMI less than or equal 30. And then off the top of this, I'm going to say charges, yes. And then I'm going to say dot mean. Perfect. 10,782. Next question. How many men smoke? Okay, for this, I'm going to say, again, we have two conditions, DF brackets, one for the first condition and another parenthesis for second condition. So first condition is that the person must be male. So we have done this a few times. I'm going to just copy and paste this. Second condition is that smoke, yes. So DF smoke must be equal, and then yes. So if I just run this, I get, oops, what happened? Variable smoke. It's not called smoke, it's called smoker. So there's R at the end. Let's run it again. Now, perfect. Now I have all the males who smoke. And then I want to count them. So I'm going to say equals shape. And then it's a tuple, so I can extract the first element. And 156. So 156 male smoke. Perfect. So let's keep moving, create a new conditional column. Let's say we want to create a new column called status. And its conditional column is based on age. If age is greater than 75, status will be old. Otherwise, if age is greater than 35, status will be middle age, and then otherwise status will be young. So first I'm going to run this function, def banana, if x is greater than, oh, not, let's make this 75, let's make it 60. Banana, if x is greater than 60, return old. If elif x is greater than 35, return middle age, else return young. I'm going to just run this function. And then when I run that function, I'm going to get this. Df status. So I'm creating this column df status based on column df age. And so on the right side, I'm going to have df age dot apply banana, the function, yes? So, and then on the left side, whatever you want to be created, which is df status. So just run this. And if I ask Python to show me the first 20 observations, Python does it. So now I can see that I have this variable status. It's young, middle age, and every now and then I have old. So for that, I got to take a look at the age. If age is less than 35 or less than or equal 35, I'm getting young. Greater than 35, I'm getting like here 46, middle aged. And then if they are greater than 60, like here, which is 62, I'll get old. Perfect. That's how we created a new column. First, you define a function, and then you create a function, a new column based on that function. So delete this, now delete it. It was just for instructional purposes. Now we can delete this df. And then take a look at this df. Now that fun column status is gone. Okay, perfect. Now we have a question here. Now you create a new column called child frequency. If children equals 0, child frequency will be no child. If children equals 1, child frequency will be 1 child. Otherwise status, otherwise child frequency will be many children. So it's a column that I want to create. First, but how about you create a function. How do we create a function? Very easily. DEF. Maybe here I call it peach, whatever you want to call it. And then we have X colon, and I say if X equals 0, then return no child. Elif X equals 1, then return one child. Else return many children. Okay, now that's a function. So you first you run this function, and then you apply this function to the appropriate column. So the column that I want to create is this on is going to be on the left side, df quotation, and then create a new column called child frequency. So I'm gonna create this column called child frequency, and then equals df. So what column here do we have? Children. Copy and paste it from here. df children, and then dot apply peach. So now if you run this, hopefully we have done everything correctly. To test if we have done everything correctly, we are going to print first 20 observations. So I'm going to say df.head 20. And yes, as you can see, if this person has 0 children, we are getting no child. If the person has 1 children, we're getting 1 child. And if they have, for example, 3 children, it's going to be many children. Yes. Okay, that means we have done everything correctly. Okay, let's do some statistical analysis. Do the t-test, yes? So I want to compare, for example, charges for people. In sample, what's the average charges for people? So here we want to do a t-test. T-test is used to compare means of two populations. Now, so the question is that we want to, for example, compare two populations. One of them is people 45 and older, and people younger than 45. Before doing the t-test, we can also just take a look at the samples and see what's the average charges for people 45 and older. So this part has nothing to do with the t-test. We are just gathering information about the sample. Average ages. So first we are gonna just select population 45 and older. So you see that everybody is 45 and older. And then we say on the top of that, we say charges and then mean, yes? So this is average charges for people 45 and older, 17,163. People younger than 45, 13,273. Okay, now we want to compare if these two populations are being charged differently. So we say sample one, DFDFH 45 and older charges. Again, when you're doing the t-test, you don't need mean. As a matter of fact, if you write dot mean here, it's going to be incorrect. It's not going to give you the correct answer. And then population younger than 45, and then just p-value. And here we ask Python what's the p-value, what p-value is. And as you can see, it's like 1.12, 10 to power negative 21. That means we have like 21 zero decimals. Yes, it's going to be like 20 decimals and then 1, which is way easy, which is way smaller than 0.05. Whenever you see this scientific letter E, that means your p-value is less than 0.05. So we say that since p-value is less than 0.05, we reject H0. Means of two populations are statistically different. Perfect. Now, so we did that one. Let's do something ourselves, yes? So in the sample, what's the average charges for men? What's the average charges for women? Test the hypothesis that in the population, average charges for men and women are the same. And what's the conclusion? Yes. So pause the video and do these questions yourself. Hopefully you have done this correctly. So I'm going to start like this. DF, average charges for men. I'm going to say DF here. The variable is called sex. DF sex equals male. That should give me population of all the men. And then average charges. So I'm going to say here charges. By the way, I forgot to delete this variable child frequency. So I'm going to just add that here. Del DL and then child frequency. That was just a practice, yes. Okay, good. Now if I do this, I'm not going to see that. Yeah. Charges and then dot mean. So average charges for men is 13,953. For women, I can just copy and paste this and then change male to female. And 12,576 dollars. So women are getting charged less than men. Now we want to do the t-test. So for t-test, I'm going to just copy and paste these 4 lines. And then change this right side of here. And then second one is going to be the same, but I'm going to change male to female. Now, I want to see, as a matter of fact, we are checking this. Is the gap between how much male get charged and how much female get charged, is it big enough to just judge the whole population and say men and women are getting charged like different numbers or not? So just run these 4 lines. P-value is 0.39. Since p-value is less than 0.05, we are going to say that means of two populations are statistically different. Perfect. Okay, after this, let's do correlation. Now, what's the correlation between age and charges? So it's going to be Pearson R, df age and df charges, and then 0. Yes, it's 0.3. What's the interpretation of this correlation coefficient? It means as age increases, charges increase as well. Next one is for yourself. What's the correlation coefficient between children and charges? Pause the video and do this. Hopefully I've done this correctly. It's going to be very similar to this. I'm gonna copy this and then change age to children. And then run this and 0.07. So it's not that much of a correlation, but still a little bit positive. Okay. Next topic that we have is about data visualization. Let's do some data visualization. So question 1 is this. Plots a histogram of age with 8 bins. Color must be red. Edge color must be black. Figure size must be 9 width and 5 height. Call x-axis age, y-axis frequency, and title of the histogram must be age histogram made by your last name. So I'm going to say plt.figure fixed size. I'm asked to provide 9 by 5. I just say fixed size equals in parentheses 9 comma 5. Then here plt, this is the main one, the most important one. plt.hist, inside parentheses, the column that I'm interested, which is dfh, comma, bins equals 8, color equals red, edge color equals black. And then X label age, Y label frequency, title, age histogram made by Azizi. And I'm going to select everything and then just run it. And I can see that, oh, I got the histogram right here. Perfect. Next one is a scatter plot. Age on the horizontal axis, charges on vertical axis. I want to see the relationship between age and hospital charges. Earlier we saw this relationship between these two. Yes, I saw that. So Pearson correlation coefficient between age and charges is positive. Yes, 0.3. But I want to make a scatter plot and visualize that. So how can I do that? So it must be 7 by 5. So I adjust this fixed size to 7 by 5. df age on horizontal axis, charges on vertical axis. I want the color, for example, to be green. And I want the marker to be, for example, letter O. And title is going to be age charges made by Azizi. And then just run this. And you can see the scatter plot. Perfect. Now, as a practice, please do these two questions yourself. Plot histogram of BMI of 7 bins. Color must be blue. X label BMI, Y label. Okay, so scatter plot is going to be very similar to this. I'm going to just copy and paste this. So I want this. 9 by 5 is fine, but number of bins is going to be 7. First of all, the variable is going to be BMI. Bin 7, and then color here, we want it to be blue. Age border, age color doesn't matter. X label is going to be BMI. Y label frequency, and then here I'm going to call it BMI histogram made by Azizi. Yes, that's it. So you just run this, and then we see this BMI, histogram of BMI. Yes. Okay. Now, if you haven't done this, please do this. Plots a scatter plot of BMI versus charges. So BMI on horizontal axis, charges on vertical axis. So I'm going to copy and paste this code now, the scatter plot. And rather than age, I'm going to say BMI. I want the color to be green. That's good. Marker O. And then this one must be called BMI charges made by, yeah. By the way, maybe we can have title after X label and Y label, so we can be consistent between here, scatter plots and histogram. So just for the sake of consistency, I just do this after Y label. Okay, BMI charges by Azizi, X label BMI, and then I just select everything and I run it. Yes, that's it. Perfect. Next topic that we have is about regression and prediction. So let's take a look at DF one more time. Or DF head, huh? So here we have variables age, sex, BMI, children, smoker, and charges. Variable charges. So the question is this: predict charges based on all other regress charges on variables age, sex, BMI, and children. So here I don't have variable smoker, but I have the rest of them, yes? Now, how can I do this? So first, you want to convert this female and male to zeros and one, and smoker no and yes to 0 and 1. So at the beginning, I'm going to create a dictionary, which is a dictionary, a nested dictionary. Each column that you want to make a change is going to be one key, then column, and then the values that you want to change. So I want female to become 0, male to become 1, comma. The next variable is smoker. I want no to become 0, yes to become 1. I just run this. And now you can see that sex is 0, 1, 1, 1. And then smoker is 1, 0, 0. Yes. So I just changed everything. Yes. I converted sex to 0 and 1 and smoker to 0 and 1 as well. Perfect. I can ask Python to show me the D types. Now I can let sex and smoker are integers. So we can use them in regression. If they are like, let's say, just strings, I can't use them in a regression. Now the question is this: regress charges on variables age, sex, BMI, and children. The format again is this: name of the regression on the left side equals OLS parentheses the whole equation on quotation marks. So in a dependent variable on the left side, which is charges, and then tilde sign, then all the independent variables that you want to include: age, sex, BMI, children. I haven't included smoker, but still. So if I do this, I get the result back. Now we want to do a prediction. I'm 39-year-old male with 0 children and BMI of 22.6. My brother is 42-year-old male with 1 child and BMI of 25. How much hospitals will charge me? How much my brother? So I'm going to create a data frame. 39 and 42 is age of 2 observations, sex 1 and 1, male and male, BMI 22.6 and 25, and number of children 0 and 1. Number of children 0 and 1. So here I'm going to predict both of them at the same time. So I'm expected to be charged 10,741, and my brother is supposed to be charged 12,796. Perfect. That's our predictions. Awesome. Now you do this. Regress charges on only variables age, sex, and BMI, and then do these predictions. I'm a 39-year-old male with BMI of 22.6. My brother is 42-year-old male with BMI of 25. How much hospitals will charge me? How about my brother? So here we are going to use only age, sex, and BMI. I'm not using the variable children for this regression. So first, do the regression. Maybe the easiest way is to just copy and paste here. So regress charges on variables age, sex, BMI. Not children. I'm going to get rid of children. And then just the rest of it, just run. And then these two observations, again, I can copy and paste here. Age 39, 42, that's good. Sex, we are both male, good. BMI 22.6 and 25, good. Number of children, I'm going to delete this because in this part we don't have number of children. So I can call it A, I can call it another variable. But you can see that I just created this data set, and then this is the predictions. So prediction now based on only these, it's going to be 11,371 for me, and then 12,866 for him. Okay, that's it about mock project. I hope you learned a lot and you are having fun. Thank you very much, everybody, for listening.